Okay, so today we're going to really dig into this concept. Um, and I've heard it come up so much, like especially when you're talking about building systems that are robust and adaptable.
Mm.
Um, thinking about senior level interviews, like this is a topic that comes up again and again, and it's coupling.
Yeah, absolutely.
Um, and I think a good way to think about it is like how intertwined different parts of your system are. We want enough connection for things to work together,
Yeah.
but not so much that like one tiny change over here breaks everything over there.
Right. Yeah, you don't want one little change to just completely cascade and ripple through the whole system.
Yeah, exactly. And so to kind of wrap our heads around this, it's helpful to think of it on like a spectrum, right? From very loose to very tight.
Yeah, a spectrum of coupling.
Yeah. And this isn't like a brand new idea. This has been something that people have been thinking about for a long time.
Yeah, it's a pretty fundamental concept in software.
Yeah, for sure. So we're going to explore this spectrum and we'll break down the different things that make things either loosely or tightly coupled and like why we even care.
And especially in modern systems, right? Like with microservices and things becoming more distributed, it's super important.
For sure. Yeah. So let's jump in at a high level. Like what is it? What is coupling?
So basically, it comes down to how much one part of your system relies on like the nitty-gritty details of another part.
Okay.
So the more one component knows about another one's inner workings, like how it's actually implemented, the more tightly coupled they are.
Okay. All right. So the more they know about each other, the tighter they are.
Yeah, exactly. And to like really dive into this, let's break down some of the core pieces that make things coupled.
Okay. So what are those pieces?
So first, you've got the domain.
Okay. Domain.
So think of this as like a specific area of responsibility within your application.
Okay. So like different sections.
Yeah, exactly. So like if you're building an online store, you might have a domain for like managing product information
Okay.
and another one for handling inventory and like tracking stock levels. Ideally, you want these domains to be as self-contained as possible.
Okay. So they can kind of operate on their own.
Right. And the less they need to know about each other, the better.
Okay. That makes sense. So we've got these domains, like how do they actually talk to each other?
That's where pass-through comes in.
Pass through. Okay.
So this is all about how different parts of the system communicate. Is it like a direct call where one part is waiting for an immediate response?
Okay.
Or is it more indirect, maybe sending a message that gets picked up later?
Okay. So that's a big difference.
Huge. Yeah, the way information flows between those domains has a massive impact on coupling.
Okay. So it's not just about like what they're talking about, it's how they're talking.
Exactly right. Like
Yeah.
if you've got a product catalog domain and it needs to check if something's in stock,
Okay.
does it directly call into the inventory management domain and wait for a response?
Okay.
Or does it just fire off an event saying, hey, this product was viewed, maybe update the inventory count later?
Right. Okay. And that second way sounds a lot looser.
Much looser, yeah. It doesn't need to wait or know exactly how inventory management does its thing.
Awesome. Okay. So we've got domains and we've got how they talk to each other. What else?
Okay, so next up we have common elements.
Common. Okay.
So these are like shared resources that multiple domains might need to use.
Okay. I see.
Things like a database that everyone's reading from and writing to, or a logging service everyone uses, or like a shared library of helper functions.
Okay. So like common utilities.
Exactly.
Mm.
And while sharing can be great to avoid duplicating code, it also introduces coupling.
Oh, how so?
Because now if you change that common thing, it could break all the domains that rely on it.
Right. So it's a trade-off.
Definitely. Yeah, it's a balancing act. You want to reuse code, but not create too many dependencies.
Okay. That makes sense.
Uh-huh.
So what's an example of that with the online store?
Sure. So imagine both the customer accounts domain and the order processing domain are reading and writing from the same users table in the database.
Okay.
Now, say you need to make a tiny change to that table, like adding a new field for customer preferences. Even though that change might only be relevant to customer accounts, suddenly order processing might break because it's also tied to that table.
Right. Yeah. They both depend on it.
Exactly. And that's how a common element can create dependencies.
Got it. All right. So domains pass through common elements. What else are we missing?
The last piece of the puzzle is content.
Content. Okay.
So this is the actual data or the functionality that's being exchanged between these different parts of the system.
Okay. The stuff they're actually sending to each other.
Precisely. And the more one component needs to know about the structure of the content it's receiving,
Okay.
the more tightly coupled they become.
So it's not just that they're talking, it's what they're saying and how much they need to understand it.
Exactly. It's like if you order a package, you don't need to know what kind of tape the sender used or how they packed it.
Right. You just care about what's inside.
Exactly. You don't want to be coupled to those details.
Right. Okay. And how does that play out in software?
Think about an API call. If one service sends another a really complex JSON payload with tons of fields,
Okay.
and the receiving service expects all those fields to be there and to be a specific type that's tight coupling through content.
Okay, so it's brittle.
Very brittle. Yeah, any little change on the sending side could break the receiver.
Wow. Okay, that makes sense. So we've got these four things: domain, pass-through, common, and content.
Yeah.
Um, so now let's step back and look at how this all plays into that spectrum of coupling we were talking about, right from loose to tight.
Right.
So let's start with loose coupling. Like, what does it actually mean for a system to be loosely coupled? And like, why is that generally a good thing?
So loosely coupled systems, they're all about components that are mostly independent.
Okay.
They don't rely on each other's implementation details. Too much changes in one part don't cause a domino effect.
Right.
They usually interact through well-defined interfaces and use ways of communicating that are less sensitive to changes like asynchronous messaging or data formats that are flexible.
Okay, so it's about setting clear boundaries.
Exactly. You want each component to do its job without being too nosy about how others do theirs.
Right. Okay, so back to the online store.
Right.
What would a loosely coupled interaction look like?
Okay, so say the order processing service needs to know when a new customer is created.
Right.
Instead of directly digging into customer management's database, it could just listen for a customer-created event.
Right.
This event would only contain basic info like the customer ID.
Okay.
Order processing can do its thing without knowing how customer management stores the rest of the details.
Awesome. So it's like they're aware of each other, but not too involved.
Exactly. And that brings a ton of benefits.
Like what?
Well, first, you get better modularity, which means each component can be developed, tested, and deployed independently.
Right.
It makes the system super flexible, easier to adapt and add new features.
So if I want to add something to the order processing, I don't have to mess with customer management.
Exactly. You're not tripping over each other.
Cool. And what about like if something breaks?
Well, loosely coupled systems are generally more resilient.
Okay.
If one part fails, it's less likely to bring down the whole thing.
Got it. So it's like containing the damage.
Exactly. You've got these isolated compartments, so problems are more contained.
Awesome. Okay, so that's loose coupling.
Mm.
Now, what about the other end of the spectrum, tight coupling? What are we talking about there?
All right, so tight coupling is when components are super dependent on each other.
Okay.
They often share data directly, make lots of direct calls, and rely on very specific formats.
So any change could be a nightmare?
Pretty much, yeah.
Huh.
A small tweak in one place can ripple through the whole system.
So it's like a house of cards.
Yeah, that's a great analogy. Touch one card and the whole thing could topple.
Right. Okay, back to our online store. What would be an example of that?
Imagine if order processing needed customer info and it directly accessed the internal data structures of customer management.
Okay.
Now, if customer management changes how it stores that data, order processing is going to break.
Wow. Yeah, it's totally dependent on it.
Exactly. That deep knowledge of another component's internals is a classic sign of tight coupling.
Got it. And what are the consequences of that?
Oh, it can get messy, especially as the system grows.
How so?
Well, it becomes way harder to understand, modify, or extend anything.
Okay.
Deployments become risky. You often have to deploy multiple components at once in a very specific order.
Wow.
And it can even slow down teams because everyone's stepping on each other's toes.
Right. I see. And what about if you need to like refactor and make big changes?
Oh man, refactoring a tightly coupled system is like untangling a giant knot.
Right. It just cascades everywhere.
Exactly. It can become a huge project.
So it sounds like loose coupling is the way to go for sure.
It's definitely something to strive for. It makes your life so much easier in the long run.
Right. And for someone preparing for a senior level interview, this all seems really important.
Oh, absolutely. Being able to talk about coupling the different types and why it matters is crucial for senior roles.
Okay, so they should really understand this spectrum.
Definitely. And be able to explain the trade-offs between loose and tight coupling.
Okay, so it's not just about knowing the definitions. It's about understanding the impact.
Right, exactly. And also having some practical examples of how it plays out in different scenarios.
Awesome. Okay, so let's zoom out for a second and think about the history of these ideas, because it feels like this isn't just a microservices thing, right?
Not at all. Even back in the days of monolithic applications, people were grappling with these same concepts.
Right, so where did it all start?
Well, way back in the era of structured programming, you had pioneers like Larry Constantine and Edward Yourdon.
Okay.
They did a lot of work on something called structured design.
Structured design.
Yeah, and they were all about breaking down systems into modules and figuring out the best way for those modules to interact.
Right.
And they stress the importance of minimizing coupling between those modules, even within a single application.
So it's not a new idea.
Not at all. It's just evolved as our systems have become more complex and distributed.
Makes sense. And is there anyone else we should know about?
Yeah, there was another influential figure, Myler Page Jones. He wrote a book called The Practical Guide to Structured Systems Design. And he really dove deep into managing dependencies and making sure that changes in one part of the system wouldn't have a ripple effect.
So it's all about controlling those ripple effects.
Exactly. And even though these ideas came about in a time of monolithic apps, they're just as relevant today with microservices and distributed systems.
So the underlying principles are still the same.
Absolutely. It's all about creating clear boundaries between components, whether those components are functions, classes, or entire services.
So it's like a fundamental design principle.
Exactly. And by understanding how coupling can manifest through shared data schemas, communication protocols, or functional dependencies, you can make better decisions as a software architect or developer.
And that's what will set you apart in a senior level interview.
For sure, being able to articulate these concepts and give concrete examples of how you've applied them in real-world systems shows that you're thinking about the long-term health and maintainability of the software.
So it's about seeing the bigger picture.
Exactly. It's about going beyond just writing code that works and thinking about how that code will be maintained and extended over time.
Awesome. So to wrap this all up, it sounds like understanding coupling both loose and tight and all the different factors that contribute to it is crucial for building great software.
Absolutely. And it's not just theory. It has a huge impact on how easy or difficult it is to work with a system.
Right. And for anyone out there prepping for those senior level interviews, being able to clearly explain these concepts and give examples of how they've played out in different situations is a big plus.
It shows you're thinking at a higher level about architecture and design, and that you understand the trade-offs involved in different approaches.
Awesome. So as you're preparing, think about systems you've worked on or encountered.
Yeah.
Where have you seen loose coupling make development smoother, and where has tight coupling caused headaches?
Great point.
Really digging into those real-world experiences will help you solidify your understanding and give you great examples to talk about in those interviews. All right, folks, thanks for joining us for this deep dive into coupling.
Thanks, everyone.
We'll see you next time.
See you later.